Hello again, everybody, and welcome to the fourth edition of our Wastewater Challenges webinar series. At BioLynceus, we recognize that wastewater challenges are dynamic and unique. To address this fact, we've launched a webinar campaign with the goal of addressing a number of common wastewater issues. So far, we've covered nitrification, F2M, and fog reduction. So if you're having trouble with any of these issues, be sure to check out these webinars by clicking on the topics at the bottom of the page. Today, I'm going to be talking to you about one of the biggest issues in wastewater today: solids handling, specifically that of sludge reduction. Sludge is a natural byproduct of the wastewater treatment process that accumulates and requires additional processing. Sludge is a slurry of organic and inorganic solids. The organic solids are volatile solids like cellulose and microbial cells. The volatile solids component of sludge can be degraded using bioaugmentation. The inorganic solids are inert solids like sand, silt, clay, and trash and cannot be degraded biologically. Solids accumulation is unavoidable, so wastewater facilities are constantly looking for ways to efficiently handle these solids. Many facilities are turning to processing their sludge for secondary applications. The sludge is partially dewatered, most commonly by centrifuge or belt press, and then hauled to either farms for fertilization purposes or to landfills where it is used to cover domestic trash. Recognizing the utility in recycling human waste, the Federal Clean Water Act Part 503 identifies two categories of pathogen reduction for biosolids. Class A biosolids undergo a process to further reduce pathogens. This is also known as PFRP. This process removes all detectable pathogens and allows for biosolids to be used where public contact is likely. Class A biosolids can be used on golf courses, home lawns and gardens, and at parks. Class B biosolids undergo a process to significantly reduce pathogens. This is also known as PSRP. This process removes most pathogens, but contains some detectable contaminants. Using Class B biosolids requires additional best management practices, and site permits are required when applying Class B biosolids. Class B biosolids can be applied to crops not intended for human consumption, things like alfalfa or hay. These biosolids can also be applied as a cover at landfills. There has been some pushback over the years on the use of biosolids due to the unknown human health effects and potential pollution of fresh waterways. Biosolids are known to contain heavy metals, excess nutrients, pathogens, pharmaceutical residues, and many more chemical irritants. And even the EPA acknowledges that more research is needed to, quote, reduce persistent uncertainty about the potential for adverse human health effects from exposure to biosolids, end quote. Only time will tell whether the long-term application of biosolids is safe. But for now, it's hard to argue with the idea of recycling an inevitable byproduct of human waste. When it comes to managing your solids, there's a couple things you can do. Many mechanical plants have the option of wasting sludge at their leisure. That is, sending it to a digester before ultimately processing it for secondary applications. Some mechanical plants utilize sludge holding ponds, but either way, the sludge will need to be handled. Lagoon treatment facilities don't have the luxury of being able to waste sludge. For these facilities, handling sludge is a constant battle. Lagoon facilities that have excess sludge must figure out a way to dispose of their sludge. For many facilities, this means mechanically dredging with some periodicity, usually every couple years or so, depending on flow and holding capacity. Unfortunately, mechanically dredging is very expensive, usually somewhere between $300 and $500 per dry ton of sludge. This means the sludge must be extracted, dewatered, and then hauled away. The exorbitant costs are not the only thing that makes this option undesirable. Mechanically dredging could cause damage to lagoon liners, leading to the unwelcome interaction between raw sewage and groundwater. Mechanical dredging is ultimately unavoidable. Even with adequate biodegradation of sludge, inert solids like sand, silt, clay, and trash cannot be degraded. These inorganic solids will slowly accumulate and will need to be occasionally dredged. What we recommend is the use of bioaugmentation. Properly deployed, bioaugmentation can significantly reduce the amount of sludge in both mechanical and lagoon facilities. Bioaugmentation for the sake of degrading sludge is something we at BioLynceus have coined probiotic dredging. Probiotic dredging utilizes bacteria to break down the volatile solids component of sludge, converting complex carbohydrates like cellulose into biodegradable food sources like glucose. To reiterate, inert solids like sand, soap, and clay cannot be degraded, but probiotic dredging can drastically reduce the cost and frequency of mechanical dredging. The application of probiotic dredging can therefore be seen as a sludge maintenance program, reducing the amount of sludge that needs to be dealt with. So with that, let's get brave and dive deeper into the science of biodredging. Microbes such as Cellulomonas that specialize in sludge reduction must turn cellulose, or sludge, into something they can eat. To do this, the microbes release amylase enzymes that hydrolyze the chemical bonds between the glucose mers that make up cellulose. The glucose represents soluble, carbonaceous BOD that can be degraded by the microbes. This process is illustrated in the figure to the right. According to Wastewater Bioaugmentation and Biostimulation by Michael Girardi, if 1 pound of glucose is degraded, approximately 0.6 pounds of microbial cells, also known as sludge, is produced. The remaining mass is converted to water and carbon dioxide. This relationship is shown by the equation at the top of the slide. If you're looking to reduce solids without physically handling them, our best recommendation is to administer a live microbial product with bugs that produce amylase and can degrade the bioavailable material. Our flagship product, Probiotic Scrubber 2, also known as PB2, is one of the best products in the business at biologically removing sludge. This proprietary blend is loaded with several species of sludge-degrading organisms. Using PB2, you will not only see a reduction in sludge, you will also see an enhancement of regular wastewater operations, things like fog reduction and increased nitrification. Additionally, all of our proprietary blends come ready to use, which means no maintenance for busy wastewater operators. Like all of our products, all you need to dose is a peristaltic pump. You can also use your hands if you prefer, as all of our products are certified organic and safe to handle. Our products come in 5-gallon pails, 30 and 55-gallon drums, as well as 275 and 330-gallon totes. These products are ready to be shipped today. If you want more information, feel free to contact us. Our business hours are Monday through Friday from 8 a.m. to 5 p.m. Mountain Time. Give us a call or visit us on our website, BioLynceus.net. Feel free to use the chat bot at the bottom of the webpage to submit any questions you might have. This may take a minute to appear, but if it never does, you can submit your questions by clicking Get a Free Quote. If you submit a question, someone at BioLynceus will get back to you as soon as possible. That wraps up this edition of our webinar mini-series. I'd like to thank you all again for joining us, and I hope this information helps you in your quest to remove solids either from your mechanical plant or your lagoon. Be sure to check back in the coming weeks for more webinars. Thanks for stopping by, but mostly stay classy.